Okay, so now let me give you some examples of some specific rotations. So keep in mind that the coordinate system of the ball is supposed to be projected by lasers on the ball rather than printed. So as I rotate the ball, the coordinates are supposed to stay in place. I can't do that here, of course, so you're going to have to bear with me. Okay, so consider a point which lies at the intersection of our ball's equator and its prime meridian. That's going to be our starting point. And let us perform an up rotation. So that means moving the ball like that, theta degrees, which is about 70 degrees. So the result of that is that our point is going to move from here to there. That's about 70 degrees. And now we're going to perform a right rotation. So that means moving the ball like that, about 70 degrees. And that's going to result in the points moving on this line of latitude 70 degrees, which takes in about there. Now, notice that something really interesting happened. When we performed our second rotation, our right rotation, the distance traveled by our point was relatively short. But when we performed our first rotation, that took the point from here to here, which is a much greater distance. And the reason for that is that in our first rotation, our starting point was very, very far from the axis of rotation. In fact, it was as far as it could be. Whereas in the case of our second rotation, the point was relatively close to the axis of rotation. We just considered the result of performing an up rotation followed by a right rotation. Let's see what happens if we do it the other way around. First, a right rotation, and then an up rotation. So we're going to start in the same spot as before, the intersection of our ball's equator and its prime meridian. And we're going to rotate theta degrees about the axis that crosses the north and south poles. So that's about 70 degrees, and that takes us around there, which is close to the Maldives. And now let's perform our up rotation, which is a rotation about the axis where my finger is. So that's going to take the point to about that location. That's about 70 degrees. So it's that point near the Indian coast. Now, notice that the same thing happened as before. Our second rotation resulted in the points traveling a relatively short distance. And our first rotation resulted in our points traveling a much greater distance. And the reason is the same. It's to do with the distance between our point and the relevant axes of rotation.